It is Tuesday, right? We are supposed to be here. There we go. Not in here yet. Yes. Oh, I didn't forget. Morning. All right. Well, good morning, Zoom people. We have a full house today. I'm so happy. Full house. My uh steady five that are face to face. Okay, so what we're going to do today is we're going to, first, just some housekeeping things. So we had to turn in progress reports. It's called early alert progress reports. If you didn't get anything email wise, then you're good to go. You're in the mid 70s and above. If you did get an email, that means that your grade is in jeopardy. So just reach out to me. Let's talk about some strategies to make sure that you're getting your homework in, that kind of thing. So if you have any questions on that, and that's across the board. So all of your classes, if you don't hear anything, that means your grades are in good standing. And also your grades in Canvas are always up to date. So as long as I'm on top of my homework, my grading, your grades will be up to date. So you should know at all times what your overall grade is. So again, make sure that your grade going into the final, if your grade is in the mid 80s, you can, I don't want to give you permission, but if you bomb the final, you're still in good standing. So basically the final can drop your grade by about half a grade. So if you're at a low C, it can drop into the D range. So you want to make sure that you have a solid B. So in the 80s, a solid B range. And that way you don't have any worries. You don't have to, stress about the final. You do the best you can and move on. Okay, so any questions on that? Okay. All right. So what we're going to do today is we're going to kind of review and go over some more linear equations, and then we're going to get into graphing. And so we basically have 3 homeworks this week. I separated out 2 of the graphing ones because one's intercept method and one is slope intercept method of graphing. So I wanted you to have 2 completely different homeworks. So it really is one homework, but I split it into 2. So that's why there's 3. And then we have a quiz. So the 3 homeworks are due the 20th, so Friday. And then the quiz isn't due until the 25th. And the reason for that is because it gives you practice on the 3 graphing, or the 2 graphing techniques, so that you'll be ready for the test. So your first test is coming up September 26th. So for you guys, you'll come in, you'll take your test. It's a paper test. For those of you on Zoom, what's going to happen is right before class, I will upload the test. You can either print it or use separate paper to write, show me all your work, all of that. So it might take you a little bit longer, just because you have to, not necessarily rewrite the questions, but you have to show me all your work. Or you can print it. There'll be a document that you can print. And then you'll have your cameras on, your mics off, but your cameras on in Zoom. And then you'll take your test and then you'll upload it to the class. So you guys will just turn yours in. Okay. All right. So that's coming up. So what you should be doing is review. Go back into your packet and everything that we haven't done. You have all the answers. Just keep practicing. And That's the best way to prepare for the first test. Okay, so let me share my screen here. Okay, so what we're gonna do, get stuff out of the way. Okay, so what we're gonna do is this is just kind of prep some more review of linear equations, being able to solve an equation with one variable. So these first four are called one step. We already went through one step. So go ahead. So this is page, what page is this? This is page 61 in your packet. So go ahead and just pick any two, pick either one or two, and then pick 3 or 4. So one with adding and subtracting and one with multiplying and dividing. So just do 2 of those 4, one of each. Either do 1 or 2, and then do either 3 or 4. So with all of these, how this relates to graphing is all of these equations are linear in nature. So if we were to graph any of these, they would end up being a line of some sort. Could be a perpendicular line, could be a horizontal line, a vertical line. And then what I'm going to do is just go through and write the answers in. I'll do them each one. And whichever one you pick, make sure yours is correct. And if you have a question, don't hesitate to ask. $42 divided by 3, is that 14? Did I do that right? Okay. Let's see. 14. Okay, so any questions on those 4? All one-step equations, whichever 2 you did, just double check, make sure yours is right. So I do have a question for you. When you're doing these, so look at number 2. Number 2, we subtracted 5 from both sides. Makes sense because, again, we're trying to get y by itself. But why did I divide on number 4? Why did I divide by a -3? What's the difference between them? Why is one positive 5, and the other one is -3? What's the difference? Okay, it does have a negative sign in front. But even on number 1, there's a negative sign in front of 7. By doing what? Dividing, right? Did you say that? Did I just miss it? Oh, okay. All right. So Jonathan said the reason why we're doing that is because with number 2, you're eliminating a positive or an addition by subtracting. In number 4, we're eliminating the -3 by dividing. So make sure that you pay attention to that because that does come into play. Variable. Yes, so you need the variable on its own. And then with number 4, you're correct, Nathan, there is nothing to add or subtract. And again, we're doing opposites. Okay, so on the next one, number 6, what's the error? Because if you can find your errors, you're going to be a better math student. So on number 6, what's the error? What's the mistake that's made? Mm-hmm. Okay. And why can't I divide by 4? Exactly. It'll be if I did it this way, this would become 2x equals 1. So I haven't done anything, right? I haven't isolated that x. So you always want to divide by the variable next, or the coefficient next to the x. So this is incorrect. So to correct it, we're going to have 8x equals 4, and then we're dividing by the 8, which makes it x equals 1/2. So you can see big difference, right? This is the correct answer. This is the incorrect answer, and they're inverses. All right, so, and I have seen that happen. I have seen people, especially if they have something like, let me get a different pen, it's too thick. Especially if they have something like 4 equals 8x. This is where that mistake is made, because you're so used to dividing by the left side. So again, this is incorrect. You always want to, it doesn't matter which side the x is on, you're always going to divide by the value next to the x, because again, the goal is to get x by itself. All right, how about number 7? What's the error? Okay. Okay, and so we want to make sure that we keep the x there. So, and I've seen this error too. So remember, you're dividing by the coefficient, not the x. Because with this one, if I do this, it becomes 1 equals 1 over 2x. Well, this doesn't make any sense, right? Because you haven't changed anything. So remember, you're only dividing by the coefficient, because you want to get that out of the way, and x equals 1/2. Okay. So those are two super common mistakes that I've seen. All right. Now we have multi-step, or we're starting out with 2-step equations. So between 8 to 11, just pick any 2 to practice. So these are 2-step equations. So which one are you going to get rid of first? Good. Good. The number without the x. So the plus or minus goes first, and then adding in or multiplying or dividing. So pick one from this and one from this, either 8 or 9 or 10 and 10 or 11. And hopefully you'll do this so much that you see a pattern and you follow the pattern every single time. It's always going to be get rid of the plus or minus, and then multiply or divide. Plus or minus, multiply or divide. And then once you're done, take a look, see if you have the correct answer. I did all 4 of them. So any 2 that you chose, make sure you have the right answers. And this is one of the most basic algebraic processes. That's probably one of the most important, because everything comes back to being able to solve a linear equation, at least in the linear equation. Everyone good? All right. Okay, spot the error. Number 15. And anyone in Zoom can answer too. What kind of mistakes are they making? Okay, and how is that, how does that change what they have up there? So what is it going to equal? Okay, so it's going to equal 0, right? Which still, they, you know, is it wrong? Not necessarily. They're just making more work for themselves. So there's definitely a strategy for these. And the strategy is you want to make sure that you put the numbers on one side. Good, Yahira. The numbers on one side and the variables on the other. And again, it doesn't matter which side you go to. You just be consistent. Just try to be as consistent as you can. So Yahira says we're going to take the 3 away. So what I want to do is I want to show you how many fewer steps we have, right? So -9 minus 3 is -12. Then we're going to divide by -4. So x equals +3. So even though they got the exact same answer, their technique is a little bit skewed, because you can't just get rid of a number on one side of the equal sign and not have an equal sign anymore. That equal sign has to stay. So the way that they did it was a little bit funky, a little bit weird, but you always want to make sure that you have your numbers on one side and the variables on the other. Always. You split them. You put one on one side of the equal sign and one on the other. Okay? Now, yes, exactly, Daniel. You have to keep the equation balanced. Good. So that equal sign is your balance fulcrum. Okay, so if this was a test and you were the teacher, I know none of you guys are going to be teachers, but if you were the teacher, if I was grading this, or if you were grading this, and this is what you were looking at, you look here and you go, well, I got the right answer. Would you give them full credit? Yeah, they do have the right answer, but they got real lucky. So luck has nothing to do with it. You have to have the correct process. So on your tests, correct, Daniel. Yeah, because if they do that again, they could get the wrong answer. So they definitely got lucky on this one. So on the test, what I'm looking for is your process right? Because if your process is right, your answer will always be right. And that's where I will reiterate to you over and over again, you got to trust the process. Don't make things up. Don't add extra steps in. Just trust the process, and the process will give you a correct answer every single time. So I'm looking for process, and that's why, like on your unit multipliers, I want you to set up all those unit multipliers, because that process, you'll get the right answer every time. There's no guesswork to it. Okay, so if this were me, and let's say this was worth 5 points, I'd probably give you a point for the right answer. But the rest of it was incorrect. The process was incorrect. So on this one, if this was on a test, I'd only give you 1 out of 5 points. Whereas this one, you have the process right and you have the correct answer. So you get the full points. Okay, so just kind of an idea of how I grade. Okay, distributor property. So the distributor property, we've used it several times, especially like order of operations, but we've never really like seen the definition of the distributor property. So the distributor property says you have a value on the outside of parentheses, and you're multiplying that value by everything on the inside. So you're literally saying A times B plus A times C. That's what the distributor property is all about, is you're just literally distributing this value through both or all parts inside the parentheses. Okay, so 4 times x is 4x. 4 times -5 is -20. Okay, and then same thing here. We're going to multiply 4 times x over 4 and 4 times -5 over 4. So we get 4x over 4. And you can look at this as 4 over 1. And then minus 20 over 4. And then we're going to reduce it. So 4x over 4 is just x. 20 over 4 is -5. Okay, or 20 divided by 4. Okay, now this is a technique that you're going to see, and we've used it before when you're eliminating the fractions. So a different way to see this. So this is a different way. You can do it either way. So you can do it either way. So the way I like to do these is, since I'm multiplying everything through by 4 over 1, I can cross cancel. This is just that multiplication. 4 goes into itself once, 4 goes into itself once. Then same thing over here. 4 goes into itself once, 4 goes into itself once. So I end up with x minus 5. You see, you get the exact same answer. So the difference is here, this first one, I multiplied and then reduced. So I multiplied and then I reduced. Here, I reduced, then multiplied. So it does not matter which order you do it. Just know that when you reduce first, you deal with smaller numbers. Okay? So for instance, over here, number 18. Okay, so again, this is that getting rid of the denominator. So if I were to multiply through first, I'd end up with 4 over 2, multiply through minus 20 over 2y. And then I reduce it. So 4 divided by 2 is 2. 20 divided by 2 is 10y. So that's one way. That's one technique. The other technique is I cross cancel, because again, this is 4 over 1. So 2 goes into itself once. And 2 goes into 4 2 times. So this is here, let me write over here. Makes it easier. So you can see the difference. All right. So 2 goes into 4 2 times. So notice when I divide, I put my answer on top. 2 goes into 4 2 times. Once I do that, that denominator is gone now. And now, so this is the reducing part. Now I'm going to multiply. So 2 times 1 is 2. 2 times -5 is -10y. And you can see I get the exact same answer. Okay, so whichever technique you like, go ahead and do number 19. Let's see what you come up with. And the other thing to notice is these four have no equal sign. These are called expressions. And so with an expression, you can't solve for x because you don't know what anything equals. So you're just simplifying the expression. And I'll do it both ways so you can see how both ways work. You only have to do it one. Okay, so distributing 12 times x is 12x over 4. 12 times -5 is negative 60 over 3. And so you see how I'm dealing with big numbers, right? And then I'm just going to reduce. 12 divided by 4 is 3x. 60 divided by 3 is 20, right? So I mean, it's not overwhelming. It's not terrible. But as you get into bigger and bigger numbers, sometimes this multiplying through and then having to reduce can cause some issues. So now let's try it where you reduce first. So 4 goes into 12 3 times. 3 goes into 12 4 times. And then 3 times x and 4 times -5 is -20. So again, either way, I get the exact same answer. So it's your completely, is that the way? It's completely up to you how you guys want to do it. Just be consistent. That's the only thing I can say, or practice both and see which one you like better. Okay, so when you have something like number 20, this x minus 6, you need to get in the habit of seeing this as one unit, okay? It's one term. It's just like an x by itself. It's just like a 5 by itself. It's just like a 1 by itself. That x minus 6, think of that minus sign, or if there's a plus sign, that's glue that holds those two together. You can't split those up. You have to keep it together. Okay, so the idea is we're going to clear the equations of the fractions. So this is that eliminating the fraction. And what we're going to do is we're going to multiply the whole thing by a common denominator. So in this case, the denominator is 3, right? Makes sense. That's in common. So what you can do, so we're going to do both techniques. I'm going to multiply that 3 through the top. So 3 times x minus 6 over 3 equals 3 times 1 over 3. So I'm writing it out just so you can see what I'm doing. Okay. And then I can reduce. So because this is showing multiplication here, right, 3 times this, I can cancel these. Let me do this off to the side. If you were to get crazy, and there's nothing wrong with that, if you were to distribute that 3 through, the mistake that people make is they start canceling here. So they cancel here and they cancel here. The problem with that is it's algebraically incorrect. You cannot cancel when you have a subtraction or an addition sign. You can only cancel when you're showing multiplication of the value times a term. Okay, that's the only way that you can cancel. So there's nothing wrong with this as long as you rewrite it as 3x over 3 and minus 18 over 3. As long as you split it, that 3 goes to both terms. Okay, so instead of distributing, I go ahead and cancel first. And now I have x minus 6 equals 3 over 3 is 1. And then I have just a one-step equation. So x equals 7. Okay, so I'm going to redo this one. I'm going to rewrite it over here. So this is number 20. So now I can show you when you reduce first by eliminating the fraction, right? So this is that second technique. We're going to reduce first and then solve. So watch. 3 goes into 3, and remember, this is one term. 3 goes into 3 one time. I cancel that. 3 goes into 3 one time. I cancel my denominator. So I end up with 1 times x minus 6, which is just x minus 6, and 1 times 1 is 1. Okay, so now we're right back to the same equation. It's just a one-step equation. We're going to add 6, and we get x equals 7. So again, either way works. You just have to be consistent and decide which way you like better. All right, try 21. All right, everyone get x equals 6? Okay, so with the which technique do you like better, Jonathan? The what? Okay, so you're multiplying and then reducing. Does anyone like the reducing and then multiplying? Not necessarily. And it's 100% up to you which technique you like better. So with this one, so I multiplied by 4 through 4x over 4 is x, 20 over 4 is 5, and 4 over 4 is 1. Okay, with this one, with the reducing first, 4 goes into 4 one time, 4 goes into 4 one time, 4 goes into 4 one time. Now, with this, because the denominator was the same, it makes it pretty simple, right? We can just cancel the 4's because we're multiplying through by 4. And then we get x equals 6. So either way. So those of you in Zoom, is there one technique you like better over the other? Like the reduce, then multiply? Okay, good, Daniel. And again, it's a personal preference. That's all it is a personal preference. Okay, so now 22. Now we have different denominators. Okay, so the idea is you're going to multiply by a common denominator. So you can multiply the two denominators. It does not have to be the least common denominator. It just has to be a common one. Or you can do, okay, 2 goes into 4. That's kind of my trick that I use is I always look at the bigger number. If the smaller one goes into it, I'll use the bigger number. And then I know I'm at common denominator. So if you're multiplying straight across, you get 4x over 2. You get 12 over 4. And what are you going to do with that 3? Okay, you can put a 1 below it, and then what? Then multiply. Yeah. So that's just an added step that you don't necessarily need. Just remember, you're distributing this 4 through every piece. So it's equals 12. 4 times 3 is 12. And then I'll reduce where I can. So I get 2x plus 3 equals 12. And now I'm at a 2-step equation. Okay, so then for those of you who like, and I'm going to keep showing you this because once we get into larger, what's the term? More complicated processes, this reducing first actually does pay off. All right, so here we go. 2 goes into 4 twice. 4 goes into 4 one time. So notice I'm writing my answer down. And then 4 times 3. So I end up with 2x plus 3 equals 12. And so I'm right back to where. And then divide both sides by 2. So x equals 9 halves. Okay. Sorry, say that again. No, 9 halves works. Yep. If you want to change it to 4.5, you can. But personally, I like it better if you just leave it top heavy, as long as it doesn't have to be reduced. So if you had like 18 over 4, then you'd have to reduce it to 9 halves. But the reason why I keep it at 9 as a fraction, even an improper fraction, is because that's accurate. That's an exact value. So for instance, if you had, let me write here, if you had, let's say you had 3/7, right? If you change the, I'm sorry, 7/3, sorry. If you had 7/3, this would become 2 1/3, right? If you write it as a decimal, it's 2.3333, and it keeps right on going. Okay, so whether you keep it as an improper or as a mixed number, those are accurate. The decimals are not accurate. You're off by, 0.3. So that's why I just prefer to keep it as a fraction. Plus, if I ever have to do something with this, I don't have to change it back, right? If I change it to 2 1/3 and then said, okay, now multiply by 3, you'd have to change it back to the 7/3. So that's why I like just leaving them top heavy. So, and even if in the back, if you're, if I'm grading or you're looking at your answers, if it says 2.5 and you have 5 halves, it's right. So don't let that throw you. It's still correct. Okay, let's do one more. Try number 23. Okay, so common denominator is 12. Again, just the 4 or 3 won't go into 4, so then I just go ahead and multiply them. Okay, so 32 over 3, everyone got it? All right, so last one where you're reducing first. So we have x over 4 minus 5 over 3 equals 1. So again, using 12. So 4 goes into 12 3 times. 3 goes into 12 4 times, and 12 times 1. So we end up with 3x minus 20 equals 12. So exact same thing. Totally up to you how you want to do it. Okay. Any questions? Yeah, go ahead, Jade.
Can you hear me fine?
Yes.
Okay, so on 23, you got 12 for the common denominator, is that what it is? And then on 22, you got 4. But I was wondering how you got 4 on 22.
So the two denominators on 22 was 2 and 4. So you could use 8. 8 is a common denominator. But what I normally do is I look at the larger number. And if the smaller one will go into it, I'll just use the larger number. So since 2 goes into 4, 4 is a common denominator.
Oh, okay, thank you.
Okay. Did you use 8 on that one?
No, I was just a little confused how you got 4 on that one and 12 on 23.
Okay. So yeah, so if one number will go into the other one, use the common one. And then if neither one of them works, then I just multiply. And you can do that every time. The only difference is if you used 2 times 4, if you used 8 on number 22, you'd end up with a fraction that you have to reduce. You probably would have ended up with 18 over 4, and then you would have had to reduce it.
Okay, thank you.
All right. Okay, so last couple, and then we're going to move into the graphing part. So when you end up with variables on both sides of the equations, so let's jump to number 27. You decide which one you like best. If you do both of them, then you'll never get these wrong because you should get the exact same answer either way. But it's completely what one you prefer. Okay, so 27, it's showing distributive properties, so we have to distribute. You're welcome. Okay, so distributing the 6, 6 times 3 is 18. 6 times x is 6x, and then jumping over to the other side, 5 times x is 5x, and 5 times 1 is 5. And now this is that idea of get all the variables to one side and all the numbers to the other. So you literally can do this in one step. I'm going to move my 5x over by subtracting. That cancels that side. I'm going to move my 18 over by subtracting, and it cancels it on the other side. So I end up with x equals negative 13. So I just did that in basically one step. That is completely okay. If that's too much, just do it one step at a time. Move your X's over. And then move your numbers over. Either way works. Or start out doing it this way. And then once you see the pattern, then you can transition into the other way. Correct. Well, X has a 1 in front of it. Is that what you mean? Yeah, because 1 times X is X. So there's always going to be a 1 there, but we just don't write it. All right, now these last two are a little bit different because again, now we are looking at this as one unit. All of these binomials, put parentheses around them because then it makes you look at that as one term. You're dealing with that as one thing. It's not a 1 and an X. It's a 1 plus X. It's not a 28 and an X. It's a 28 plus X. Jay, do you have a question or is that the old hand raised?
I think that's the old one.
Okay, I think you can unraise your hand or there's some button. There we go. Okay. Okay, so what on 28, what this means is 3 divided by the 1 plus X. All right, we don't want that on the bottom. So just like we got rid of fractions before, we're going to do the exact same thing. We're going to take this whole thing and multiply it by 1 plus X. Okay, so if you like the technique where we multiply through the top, it'll look like this. Okay. And then what happens is that cancels this one. And I can cancel this because we're looking at that 1 unit and it's 3 times that 1 unit. So I can cancel it. Notice I'm not canceling the 1s and canceling the X's. I'm canceling the whole thing. So then I end up with 3 equals 2 times 1 plus X and then distribute. And then you have a 2-step equation. So the technique is exactly the same as when you're dealing with fractions, because that's what it is. It's a fraction. We just don't know what the X is at this point. We're going to find out. So I end up with 1 equals 2x. And because I'm trying to get X by itself, I'm dividing by the 2. So this is a great example where the variables are on the other side, on the right side. And it doesn't matter. It's okay. If this bugs you, you can always rewrite it. You can always write it by flipping it around. Just make sure you hang on to the signs. So if that was a -2 plus 2x, make sure that -2 comes along with it. Okay. Whatever it takes to make you feel very comfortable with the process. But either way, you get the same answer. Okay. All right, try 29. Okay, so the denominator is 7 plus x. I'm multiplying everything through. So I have 7 plus x on top, 7 plus x on bottom. So this is why I can cancel, because I'm showing multiplication here. And so the 7 plus x goes away here, and then I'm multiplying by it over here. So I have 28 plus x equals 14 plus 2x. And then we're going to move the 2x over. Oops. And then I'm going to move my 28 over. So I get negative x equals a negative 14. Okay, so this is where, Yuritsa, that's that question. There's a 1 in front. So in this one, it's a negative 1. So you're going to divide by negative 1. So x equals positive 14. So you're not done. If there's a negative in front of your variable, you're not done. You have to divide by the negative. And all that does is it switches the sign. That's all it does. Yeah. So did you move the x over to the other side? Okay, so you just flip-flopped them is all? Okay, that's fine. Yeah, as long as you hang on to the signs, and the only time that's an issue is if there's a negative in there. So as long as you hang on to the signs when you flip-flop it, you're good. Yeah, not a problem. All right, so I wanted to show you, any other questions on that, how I did that? Good. So I wanted to show you real quick with that second technique. So I'm going to multiply this whole thing. So remember, these are in parentheses by 7 plus x. So watch what happens. When I multiply the whole thing by 7 plus x, 7 plus x goes into 7 plus x one time. So that's that reducing first. And then I have to multiply, this is over 1. 1 goes into 7 plus x, 7 plus x times. So now I have 1 times 28 plus x is 28 plus x equals 2 times 7 plus x. So you see the techniques, either technique is going to end up with the same exact thing. So again, it's 100% up to you. But if you notice, do you see how much less work I showed? Showing the reducing first. Here, I had to rewrite it all, then cancel, and then I got the equation. Here, I just canceled and just got the equation. Okay, so it does save you some time by reducing first, especially as you get into the more complicated ones. But again, if you like the other way, stick with the other way. All right, we good? Okay, so that is leading us into linear graphs. So everything we just did is all linear equations. So on the table, so let's see. I believe so for Zoom people, I have the graph paper in the Canvas page. So you can just draw your own graphs for today, or you can do this in your prep on page 67. But there's just some, basics of graphs. This is called the Cartesian coordinate system. Cartesian coordinate system. And this is that where you have two lines intersected. The horizontal line is your x-axis. The vertical line is your y-axis. Okay, and these are these Roman numerals. This is quadrant 1. This is quadrant 2. This is quadrant 3. And you can tell it goes in counterclockwise, and quadrant 4. Now, each of these quadrants have a very special value system. All right, these are number lines. This 0, 0 point right here, this solid dot right here, this 0, 0, that's called the origin. Okay, so that's kind of where everything starts. That's your 0, 0. All right, to the right of the origin is positive. It's a number line. We'll just go up to 4. To the left, just like a number line, is negative. Okay. And then on the vertical line, the y-axis, the positive is going up. And the negative is going down. Okay, so the Cartesian coordinate system is set up that way every single time. So here's the good news. Let's see. How do I do this? I need to do this. Okay. So in quadrant 1, you have the setup is a positive x value and a positive y value. So let me back up a little bit. So x and y is called an ordered pair. That means they are always in this order. The first number is your x value. The second number is your y value. And we'll plot some points so you can see how that works. So in quadrant 1, you can see this is all quadrant 1 in here. These are all positive values. This is positive x, positive y. So any point within this quadrant is going to be both positive values. So the point that I just made right here is at the x value is 4 and the y value is 2. Okay, so you go over 4, up 2. That's how you're going to plot these points. So this is a point. We'll call this A. Okay, so based on that, what kind of values are you going to have for quadrant 2? Yeah, negative and positive, because the negative x, and then it goes up, so it's positive y. So quadrant 2 is always over here. Me using color. So if you had a point right here, and we call this point B, what would be the value of point B? Yeah, so -3, +1. So I call these ordered pairs, you can also call them the address. Because it tells you exactly where the points lie. All right, how about quadrant 3? Good. It's going to be a negative and a negative because you're in the negative side of the x-axis and you're going down in the negative side of the y-axis. So if you had a point right here, and we called this point C, what would C be? Okay, so -1, -3. So that's the address. So when you see that, you go, okay, if they're both negative, they have to be in quadrant 3. And it kind of just gives you a point of reference. All right, and then quadrant 4. What would be the x values and y values? Positive, negative, good. So quadrant 4 is all in here. And if I put a point right here, This is point D. What would that point be? Yeah, +4, -2. So you can see in quadrant A, you have +4, +2. In quadrant 4, you have +4, -2. So you have to be really cognizant of where your point will go in which quadrant. All right, so there's basically 6 things that can happen in a Cartesian coordinate system. You can have a point in quadrant 1, quadrant 2, quadrant 3, or quadrant 4, right? They will never overlap. Or you can have a point at the x-axis, and you can have a point at the y-axis, right? You can also have a point at the origin. So there's several different places that can affect the address. So if you had a point right here, and I'm going to call this E, this is sitting on the x-axis. So when something sits on the x-axis, they are called x-intercepts. Okay? An x-intercept will always have an x value, and y will always be 0. Because if the origin is 0, right, the x value for point E is 1. Oops. 1. And then the y value is 0. Then we have something called a y-intercept. And a y-intercept is when x is 0. So if I had a point up here, we'll call this one F. The x value would always be 0. The y value is wherever it sits on the y-axis. So that point would be 0. So you have a lot of things that can happen in a Cartesian coordinate system. These are just points. To do a line, we just need 2 points. Okay, so now let's fill in some of any questions so far? I'll stop there. Any questions so far? All right, so an x-coordinate is positive in quadrants 1 and 4, and negative in quadrants 2 and 3. You guys are having to learn Roman numerals. And then the y-coordinates are positive in 1 and 2, and negative in 3 and 4. So just being able to place where those values are, or where the points are. Okay, so just remember, it's always x first. X is always going to be first, y will always be second in these ordered pairs. All right, go ahead and plot those points. And we'll go ahead and name them A, B, C, and D. So you don't have to write the numbers, just write A, B, C, or D on the top. So what I like about this section is it kind of takes you away from the algebra part. It kind of gives you a little bit of a reprieve as far as working the algebra. So A was in the first quadrant, positive, positive. B is going to be in which quadrant? In 3, good. So over 2, down 5. C, where's C going to be? In 4, positive and negative. and D into, good. So -4 up 6. Perfect. Everyone good? Not so bad. I had to do this one when we were learning this. I had to do this one. It's so ridiculous. There was probably over 100 points that we had to plot, and then it spelled something. Oh my, I got really good. Yeah, it was so overwhelming because you miss one and it's like it doesn't spell anything. Okay. Number 3, plot those points. So again, we'll call them A, B, C, and D. Everyone in Zoom good? Give me a thumbs up so I know you're paying attention. Thank you, Jamie. You hear it good, Sophia, good. Okay. So again, this is just kind of the preliminaries. So remember, when you look at this, if 0 is first, is this, I gave it away. These are going to be your x-intercepts, or I'm sorry, your y-intercepts, because the x is 0. So when x is 0, that means all of these points are just going to be sitting right here on your y-axis. So here is a great way to remember y-axis. See the vertical tail? That means y-axis is always going to be on the vertical. So we have a point at 5, at -5, at -1, and at +9. All of those are your y-intercepts. Okay. All right. Number 4. Now do some x-intercepts. So x-intercepts, you have the x value. The y is 0, so it's all going to sit right on your x-axis. This is your x-axis. Okay, so there's your x-intercepts. And again, what do they have in common? All of their y values are zeros. Okay, so there's your A, B, C, and D. Okay, so now what I'm doing is, and these are extra practice, but I love them because they actually really make you think through the process. So let me get to just some terminal. We don't want slope yet. We don't want slope yet. I just want the points. Sorry if I'm making you sick. I apologize. All right, so 9. So this is one of your packet that I gave you. So in the Canvas class, guys, on Zoom, there's some additional resources, and that's where I'm pulling this from. So this is not in your math packet. This is additional, but I like it because it gives us a little bit more room to play with the graphing. All right, so go on number 9, go ahead and plot those 2 points. So for Zoom, if you want to just draw the graph and plot your points, that works too. And we'll go back to the packet in a minute. Question. Never know if this is gonna work or not. We're gonna pretend like those points are sitting right there. I think I like that. Okay, so this is the definition of any line, is any 2 points. So you only need 2 points to draw a line. So whenever you're plotting points, if you're given 2, what I want you to get used to is just drawing a line, and you're going to pretend that this is straight. And remember, it's a line. A line means it goes on and on and on forever. So there's going to be arrows on either side. So it goes through those points and continues on. It will not stop. Okay. So there's one line, and we'll figure out the slope and all of that in the next few classes. All right, number 10. So the point is -2, -5, and then the other point is 4, 1. So again, just keeping in mind, it is X first. So it's always in this order, X first, Y second. So X -2 down 5. And then the other point is X is 4, Y is 1. So over 4, up 1. And then you're going to graph your line. Drawing a straight line is very difficult. That's straight. All right, now one thing you need to always be aware of is when we're looking at a line, you actually have 3 things going on. You have the line itself, right? So when it's a solid line, that means all these points are part of the solution, okay? Then you also have the upper part, so above the line, and you have a section that's below the line. Because remember, the line keeps going on and on and on forever. Oops. Keeps on going, right? So you actually have 3 things going on. You have above the line, you have the line itself, and you have below the line. Okay? So just kind of I'm throwing things out that we're gonna see in a little bit. All right. I'm sorry if I'm making you sick. Okay, so let's go back to our packet. And we have to get ready for creating what's called a slope intercept format. Okay, so the slope intercept format is y equals mx plus b. That's always going to be the format of the slope intercept format. We're going to do 2 different ways to graph. We're going to just do one today, and then Thursday we'll do the other one. Okay, so here's what the M stands for. The M is your slope. The B is what's called your y-intercept. Okay, so remember, y-intercept was when x is 0 and your y is the value. You can also see it as B is your y-intercept. So either way you need to look at it, that's how you're going to look at it. The y-intercept is always whatever that constant is. Okay, so what this means is, in order to get it into y equals, you have to solve for y. So everything you're going to do is you're going to solve for y. Now, you're going to end up with a linear equation. So it's not going to be y equals some value. It's just going to be y equals some value times x plus another value. So you're going to use the exact same algebra skills that you've already learned. So remember, we want y by itself. This number 5 shows 2 times y. So how do I get rid of that times 2? I divide by 2. So the technique is I am dividing every single term by whatever's next to the y. So that cancels that. So I end up with y equals 3 over 2x plus, and then 8 divided by 2 is 4. Okay, so m again is your slope. So that's always the value next to your x. And we're going to talk a lot about slope in a minute. The y-intercept is at 0, 4. Okay, and because the y-intercept is a point, we have to write it as a point. You have to write it as an ordered pair. Okay, try number 6. Negative 3 times y equals 3x minus 9. Okay, so you're getting rid of the negative 3 by dividing. Remember, you're dividing every single term by negative 3. So what's 3x divided by negative 3? Good, negative x. And then negative 9 divided by negative 3? Plus 3, good. Good, Yahira. All right, so, and even though this doesn't ask you to do this, I want you to always identify the slope and the y-intercept every time you get it into slope-intercept format. So what's the slope? Negative 1. Good. It's always the value next to your x value. And then the y-intercept, 0, 3. Good. Okay, now what's going to happen is we're going to use the y-intercept and the slope to be able to graph these lines. And it makes it really easy if you already know how to find the slope and the y-intercept. It makes your life so much easier. Okay, so number 7, now we have 2 steps that we got to do. Because remember, we're peeling away everything to get y by itself. So we are going to move the x over, or the 2x over, by subtracting 2x. So once you move something across that equal sign, you do the opposite. So then I have 3y equals 15 minus 2x. So now we're right back to what we just did. We're going to divide everything by 3. So I get y equals 15 divided by 3 is 5 minus 2/3 x. Now, you can rearrange this. Again, just remember to hang on to those symbols. So because the negative is in front of the 2/3 x, I'm going to bring that negative in front of the 2/3 x. The 5 is positive, so the 5 stays positive. So what's your slope? 2/3, and the y-intercept, 0, 5. Perfect. Okay. So the whole goal is getting your y by itself. So go ahead and try number 8. Okay, so we move our 3x over by subtracting 3x. And let me ask you something. Why can't I put the 9 and the 3x together? Why can't it be like 6 or 6x? Yeah, they're not like terms. Yeah. So remember, like terms means the variable is the same and the exponent on the variable is the same. So the 9 doesn't have a variable, the 3 does. So they are unlike terms. You cannot put them together. They're two completely different things. All right, so we got 9 divided by -3 is -3. -3x divided by -3 is plus x. So I have y equals x minus 3. So again, watch those signs. Okay, what's my slope? 1, good. And my y-intercept? -3. 0, -3. Okay, so mx, m is your slope. The x value is just part of the linear equation, and then the -3 is your y-intercept. Okay, any questions on those? Anyone in Zoom have a question? Guys good? Okay. All right, so let's try one with fractions, and then we'll get into the actual graphing. So again, anytime you have a fraction, it's going to be difficult. No, it's not going to be difficult. You can still do it without having to get rid of the fraction. I just like you to practice eliminating the fraction just because it's makes your life easier. So I'm going to multiply through a common denominator. So if we're multiplying across the top, I get 6x over 2, 12y over 3 equals 24. And then reduce. So 3x minus 4y equals 24. And then you're just solving for y. So I'm going to get rid of the 3x, move it over. Then I'm going to divide everything through by -4. So I get y equals 24 divided by -4 is -6. -3 divided by -4 is a positive 3/4 x. So if I rearrange it, writing it in mx plus b form, so then I know where my slope is and I know where my y-intercept is. So the slope is 3/4, and the y-intercept is at 0, -6. Just to put it in that y equals mx plus b form. That's all. Yeah. You don't have to. If you can recognize that as, oh yeah, that's a linear equation. So the way that you know you have a linear equation is you have y to the first power and you have x to the first power. If the exponents change at all, you don't have a linear equation anymore. You should always have a y to the first and an x to the first power. That's how you know it's a linear equation. So if you are comfortable with this format right here, just know that the slope is always next to the x. The constant is always your y-intercept. Okay, I just like to rearrange it so I know for sure. There's my slope and there's my y-intercept. Okay. All right, so now, let's see. Okay, we're not going to do that yet, just yet. Okay, I do see that. Okay, so there's two different methods that we're going to be able to do the graph, or be able to graph a line. So the first method is called the intercept method. So when I say intercept method, I mean I'm looking for the x-intercept, which is I have the x value and y is 0, and the y-intercept, which is x is 0, and we know what the y value is. Okay, those are 2 points. Remember, a line, the definition of a line is any 2 points. So if I can find 2 different points and connect them, I get a line. Okay, so you know you're going to use intercept method when your linear equation is in this format. AX plus BY equals C. So the A, the B, and the C are all numbers or values or what we call coefficients. These are all the same thing. They're just numbers. The X and the Y is always going to be there. Okay. So the way that you're going to find the intercepts makes it your life very, very easy. Let's see. I'm sorry. I was on the wrong page. Right. Okay. All right. So X and Y intercepts. So let me write it again. So the X-intercept, sorry, this is page 73, is when the Y is 0. The Y-intercept is when the X is 0. Okay. So remember, what you're looking at is you have a graph. Okay. X-intercept means it's going to cross the X-axis. Y-intercept means it's going to cross the Y-axis. Okay. So the way that you find them, the easiest way is when it's in this format. But we're going to be able to do both. We're going to be able to find the X and the Y-intercept, whether it's in that format or whether it's in the Y equals MX plus B format. Okay, so because of what we just did on number 1, so this is page 73, sorry, I was jumping around. In number 1, if you notice, you're already in Y equals MX plus B format. Okay, so you already know what the Y-intercept is. Remember, the M is your slope and the B is your Y-intercept. So we're already halfway there. So our Y-intercept for this particular one is at 0, 9. That's 1 point. We're halfway there. The X-intercept, we have to calculate it. Okay, so the X-intercept, so look here, is when the Y is 0. So what you're going to do is you're going to take out the Y and replace it with 0. And now you have a 2-step equation. So that's why it's super important for you to be able to solve any equation using basic algebra skills. So we're going to solve for X. We're going to subtract 9 from both sides. And then divide by -2. So your X-intercept is 9 over 2, and your Y value is 0. Those are your 2 points. And this is where, like, if you were to graph that, you would have to know that 9/2, you can change it to a fraction or a mixed number, is about 4 1/2. So it would be a point right in between the 4 and the 5. Okay, so tell me what the y-intercept and the x-intercept on number 2 is. So one thing to notice is, okay, it's in that y equals mx plus b. It's y equals, so you know you have your y-intercept sitting there. All right, so what's your y-intercept? Okay, 0, 6. Perfect. Okay, there's your plus b right there. The x-intercept is when your y is 0. So you're solving for x. Okay, so we subtract 6 from both sides, so we get x equals -6. So your x-intercept is when y is 0, and then when you solve, you get -6. So there's your 2 points. So you're thinking slope, which is different than an intercept. So the intercept, that's why these two things right here are so important, is to know which one is your y. I mean, sorry, which one is your 0. So when you're looking for the y-intercept and it's in this format, your x is going to be 0. So if I plug a 0 in here, y equals 6, right? So that's where we get our 6. If I do the other one and I want the y-intercept, my x is going to be, I'm sorry, I'm saying it opposite. If I want my x-intercept, my y is going to be 0. So that's where I replace my y with 0 and then solve. So whatever the value the x is, that's going to be your x-intercept. Okay, so don't get the slope and the intercepts are two completely different things. Slope is how much your line is going up or going down. Okay, all right. 3 and 4, and then we'll actually graph them. 3 and 4. Now you can see it's in the format ax plus by equals c. Okay, so here's the beauty of when it's just called standard form. This is what I love about this. So when you have your x-intercept, remember, x-intercept is when y is 0, right? So if I take my y out and I plug in 0, what happens to that? It goes to 0, right? So here's the awesome part about this. This is what I love, is I can take this, cover it up, and I end up with -2x equals 6. Now, the reason why I'm covering it up is because my y is 0. So 12 times 0 is 0. I can cancel it. It goes away. So I end up with -2x equals 6. And then I divide both sides by -2. And I get x equals -3. So my x-intercept is at -3 and 0, just by covering up the y term. And the reason why I cover up the y term is because y is 0, so it dumps out. With the other one, So with write it down, with my y-intercept, my x is 0. So what that means is I can cover up the x because -2 times 0 is 0. And I end up with 12y equals 6. So you're literally, even if you just put your finger over it, if you put your finger over one of the terms, either the x or the y, the term that you put your finger over goes away because that value is 0. And then what's left is your equation that you can solve. So divide both sides by 12, and I get y equals 1/2. So my y-intercept, when x is 0, my y is 1/2. So this is what I call, this intercept method is what I call the cover-up method. Because you're literally covering up. I wish I could cover it up for you. So if I cover up the x, it tells me what I'm solving for. I'm solving for y, right? So that's going to be my y-intercept. So I end up with 5y equals 17. I'm almost done. Hang in there. So we get 17 over 5. So my y-intercept, when x is 0, the y value is 17 over 5. And then when I cover up the y term, I end up with my x-intercept because x is showing. So I can solve for x. So x equals 17 over 8. Okay. So the basic idea is no matter if you have the slope-intercept format, the y equals mx plus b, you can find the x and the y-intercept. If you have the standard format, the ax plus by equals c, then you can find the x and the y. I actually prefer the standard format because I just cover it up. Cover one up, solve for the other, cover the other one up, solve for the first one. And it makes it really nice. All right. So let's just try one and then we'll be done for the day because I know you guys have had a lot of math. You guys, your hands are probably tired. Okay, cover-up method, right? Intercept method, cover-up method. And we're going to get lots of practice on Thursday. Cover-up method. All right, so we come in here, pick which one you want to cover up. Cover one of them up, one of the terms up. You end up with 2y equals 10. So I'm solving for y. So that means this is my y-intercept. I covered up the x, so that's where your 0 is. The y equals 5. So come over here and put a point at 0, 5. Okay. Now I'm going to cover the other one up. So when I cover the y up, I end up with 5x equals 10. So I'm going to solve for x. So what I'm finding is my x-intercept. I covered the y up, and my x is 2. So it's at 2, 0. And there's your line. Connect the dots. And hopefully your lines are a little better than mine. Okay. Good. Okay. So we'll keep going on Thursday on this. We'll keep practicing. You guys are going to get really, really good at it. Okay. And then we'll talk more about slope and the steepness and all of that on Thursday. All right, you guys. That's it. Oh, so homework, as far as homework goes, you have homework 7, 8, and 9 is due Friday. And then the quiz number 5 is due on the 25th. Yeah. Oh, and the quizzes, so quiz 3 was due on Monday, quiz 4 is due tomorrow. So that's on fractions and order of operations, and that is in your canvas. Are those quizzes working out okay? Yeah. Okay, good. I figured it was a little easier than doing paper all the time. And I try to go in and make sure that the answers are right. A couple of them were not. All right, guys good? Okay, all right. I will see you guys on Thursday. Yeah, go ahead, you hear it?
Can you hear me okay?
Yeah, I can.
Okay. Just making sure. For the quiz that was due this past Monday, yesterday, I didn't get a chance to complete it. Is there still a chance to complete it, or do I just continue on to the next one?
Yeah, just continue on. I do drop the lowest quiz at
Okay.
the end of the semester. So make sure you still are responsible for the material. But yeah, just keep right on going.
Okay. Thank you.
Okay,
Thank you
all
for your
right.
time today. Bye-bye.
Okay, bye-bye. Okay, drive safe. Oh gosh, okay. We'll see you on a. All right, Jalen, are you good? Do you have any questions?